welcome at the Science Park at Johannes Kepler University in Linz, Austria. I would like to tell you today about bearingless drives, and therefore let's have a look at conventional bearings. In a conventional electrical drive, this functionality is usually provided by friction bearings or ball bearings, like this one, or this one, or maybe something like this one. But fortunately, we can replace such mechanical bearings by magnetic bearings. Here you can see such a magnetic bearing, which detects the rotor position with contact-free sensors and then stabilizes the rotor using those electromagnets, so the rotor is floating completely freely and contactless in the center of the bearing. Now we can replace the mechanical bearings that we had before with magnetic bearings, but we can also do another step of integration, integrating the function of this bearing into the motor itself. This means we will use the same stator and only one special winding set to create the torque for the drive and the bearing forces. And that's what we call a bearingless drive. Some of you may have noticed that with only one bearing point, a tilting of the rotor cannot be stabilized. Now, we can do something about this and use a disc drive. Here you see such a model of a disc drive. It's a thin steel disc and some permanent magnets on the outside. Those magnets will stabilize an axial movement of the disc and a tilt movement of the disc passively. So finally we end up with a completely magnetically levitated system where the rotor has no contact to the stator and there is no such thing as mechanical friction, there is no abrasive wear. We don't need any lubrication, and we can achieve very long lifetime. And all that comes in really handy if you're trying to build a high-speed drive. Of course, we've already prepared something for you today. You see here the model of such a bearingless high-speed drive. This is the rotor. You see on top of the rotor some demonstration impeller wheel. And here inside there's the stator with its winding system. And this stator will provide both the torque for the rotor and the radial stabilization forces. And as we've mentioned before, the axial deflection and the tilt movement is stabilized passively. So I can insert this rotor here now, then have it levitate. You see it's floating freely now, and then we can use this to generate high speeds. So if you're also completely fascinated now and you want to do this at home, please be careful because at a high speed of 115,000 RPM, that's around 700 kilometers per hour of surface speed, the rotor bursts due to the centrifugal forces. Maybe kids don't do this at home. It's maybe a smarter idea to visit us here in Linz, Austria. We're looking forward to you.